Hello everyone, this is Mrs. Shaw, and today we are going to learn about explicit functions of arithmetic sequences. All right, that's a lot of big words, and don't get too worried. We're going to talk about this and explain it, so by the end of this lesson, you're going to know how to write an explicit function of an arithmetic sequence. So, we're going to start off with defining some words we learned about in last unit, and we're going to go through. You can pause if you need to write down some of these definitions as we go, but you will need them for part of your assignment. So our domain is the set of all possible inputs of a function. Okay, that is how we define domain. Range is the set of all possible outputs of a function. And our function is a relationship between inputs and outputs. For every input, there is exactly one output. If you need to pause to have time to write these down, go right ahead. We're going to learn also, we're going to define today and talk about these vocabulary words, sequence. A sequence is a function whose domain is the natural numbers, often written as a list of numbers. Okay, well, let's define what those natural numbers are. So the natural numbers are, I like to call them counting numbers, is the numbers 1, 2, 3, 4, 5, 6, etc., and so on. They're not the decimals, they're not the fractions, and they're not even negatives. And they're just our natural numbers, and we're going to use, that's going to be the domain of our sequences, our sequence functions. All right, terms. When we're talking about sequences, the terms are the numbers in a sequence. Okay, the sequence is usually a list of numbers, and we're going to call those numbers the terms of our sequence. Today, we're going to be talking about arithmetic sequence. And that is a sequence that has a constant difference. So these are lots of words we're learning. So if you can pause and write down these definitions, we'll need that. So arithmetic sequence is a sequence that has a constant difference. Well, what is a constant difference? A constant difference is, in a sequence, the constant difference is the number you add to go from one term to the next. I'm going to emphasize that add right there. It's the number we add to go from one term to the next. We're going to be doing lots of examples today, so you will be just fine. Here's an example, and I'm going to ask you, is this an arithmetic sequence? Yes or no? Well, let's look at it. This first term is 7. The next term is 10. The next term is 13. The next term is 16. Was there a constant difference from one term to the next? Here, to go from 7 to 10, from 10 to 13, 13 to 16. We were adding 3 every time. So that was a constant number. Always we were adding 3. Adding 3 stayed between each time. So that was constant. All right, oops, I went too far. How about this one? Is this an arithmetic sequence? Our first number is 8. Our second number is 6. Our third number is 4, and so forth. Remember that an arithmetic sequence is a sequence that has a constant difference. The constant difference is the number you add from one to the next. Is there a number that we can add to 8 and get 6? Yes, we can add -2. So remember, subtracting, this looks like, oh, well, we're subtracting instead of adding, but remember, subtracting is adding a negative. So adding -2 to each one, this is an arithmetic sequence. All right, so an explicit function. Here's another term that we need to know for today and define. So an explicit function is a function that helps you find any term in a sequence just by knowing its position. So these explicit functions will be very helpful, and you're going to know how to do that today. We're going to teach you. So here is a sequence that we talked about, our 8, 6, 4, 2. Oh, what would the next number be? 0. The next one, -2. Okay. We are looking, here's our sequence. If we write it as a table, remember our domain are the natural numbers. There are counting numbers. Our domain, what they're saying, this is the 8 is the first term in the sequence. 6 is the second term, and so forth. The third, the fourth, the fifth. These are just, so our domain, what we're taking our X values are just stating what position in the sequence we're talking about. So our natural numbers are our domain. Those will always be our counting numbers, 1, 2, 3, 4. Our sequence itself, this sequence of numbers right here, 8, 6, 8, 6, 4, 2, and then we can keep going 0, -2. These numbers can be anything. They could be decimals, they could be negatives, they could be different things. So as we're looking at this table, what we've done in the past is we've written our equations that we've written from tables. Remember, we figured out our change in y, which was -2, and our change in x, we added 1, and we figured out the slope. Remember, the slope was the change in y over the change in x, so our slope would be -2. Well, this information and what we've done before is going to really help us with this explicit function for an arithmetic sequence. How did we figure out here? In the past, we're like, this has been our y-intercept. This has been where our x was 0. So looking at this table, if we went and our x would be 0, how would we figure out what our y was? Or now we're looking at what our f of x is. So if we are subtracting 2 every time to go this way, remember we need to add 2 to come up. And adding 2 to 8 would give us 10. Okay, so our y-intercept is 10. Well, as we're talking about sequences, we're not going to call this a y-intercept because we're just talking about a list of numbers. And so we are actually going to call this our, whoops, I need to write that, erase that. This is going to be, so remember 8's our first number. So 10 would be our 0th number. I'm going to call that our 0th number. It's not part of the sequence. It's the number that would be before the sequence. So that is going to be where we put in this second blank here. We're going to practice some more. So here we go. Here's a sequence, 3, 5, 7, 9, 11. The first thing we need to think about is what is the constant difference? What are we doing to go from our first term to our second term? Is there a number? What number are we adding every time? Well, we can see here that we are adding 2. Wonder if these numbers were weird. Wonder if they were big numbers, or wonder if they were decimal numbers. Or you couldn't obviously see what that constant difference is. How do you figure it out? Well, you could take any number in the sequence, say I'm going to take 5, and I'm going to subtract the number before it. 5 minus 3 is 2. So taking any number in this sequence and subtracting the number before it will always give you the constant difference. All right, so if our constant difference is 2, what is the 0th number? Okay. Well, if we are looking at this sequence and going from 3 to 5, let me erase some of this stuff here. Okay, we're looking at our sequence and we're going 3 to 5, and we added 2. How would we go backwards? What would we do? You're right, we would subtract 2. And 3 minus 2 is 1. So our 0th number, the number that would come out here before that's not part of our sequence, that's our 0th number, is going to be 1. Okay, so we need to remember when we write our function now, f of x is equal to the constant difference, that is 2 times x plus our 0th number, and in this case was 1. Okay, another example here. We have the sequence 6, 3, 0, -3, -6, and so forth. So in order to find out what the explicit function is, we need to figure out what the constant difference is first, okay? Remember, the constant difference is what you are adding every time to go from 6 to 3, 3 to 0, 0 to -3. And here we can say, oh, we're subtracting 3. A lot of people can see that in their mind where you're like, okay, what are we adding? Well, you're right, we are adding -3. But if you couldn't decide, you didn't know, like you couldn't see it. These numbers were different numbers and you couldn't see that we're adding -3. Just take any number in the sequence. Let's see, this time I'm going to pick -6 this time. And I'm going to subtract the number in front of it. Okay, we got to watch out for these negatives, but that happens sometimes. So we're going to have -6. We're going to subtract -3. So -6, subtracting a negative, remember, that's the same as adding the opposite. So that would be adding 3 will give us -3. So our constant difference is that -3. Well, our 0th number. Let's go back up here and look at the sequence. And if we are to go through the sequence, if we are subtracting 3 every time, that's our sequence, that's our constant difference. What do we do to find our 0th number? To go back this way, we'll do the opposite. Instead of subtract 3, we're going to add 3. And 6 plus 3 gives us 9. So 9 is our 0th number. All right, now remember, the advantage of an explicit function is it's going to help you will be able to know what any number in the function is just by knowing what its position is. Well, we want to know what the 10th number in the sequence is. So we are going to remember the 10th number, that's our domain. So we want to find out what f of 10 is. Okay, and so we're going to plug that in for x. Plug this 10 in here for x, the 10th number, in -3 times 10 plus 9. So that's -30 plus 9 will give me our -21. So the 10th number in this sequence is -21. And you can find that out by using this explicit function. You can also find it out by just subtracting 3 every time, but if we get farther and farther in the sequence, it's so nice to have this explicit function. All right, here's another example. -3, -8, -13, -18, and so forth. What is the explicit function? Remember, this blank here, this first in front of the x, this is our constant difference. Constant difference. Remember that constant difference, how do we find that out? We just see what is happening to go from each time. What is happening every time? What are we adding to each term in the sequence? What are we adding to get to the next term? If you don't see it obvious, take any term in the sequence. I'm going to take -13 and I'm going to subtract the number before it. So -13 minus -8. Remember that subtracting a negative is the same as adding there. So subtracting is the same as adding the opposite. So -13 plus 8 gives me -5. So my constant difference is going to be -5. Our constant difference is what is being multiplied by our x variable. Well, now we need what goes in the second blank so you can remember. You're right, that is our 0th number. So how we find our 0th number, come back up here to our sequence. We know in this sequence that our constant difference, we were subtracting 5 every time to go from each number to the number. So to find our 0th number, we come to our first term, and we're going to do the opposite and add 5. So the number that would be right here in the beginning, our 0th number, is going to be -3 plus 5, which is 2. So our number here, our 0th number, is 2. It's not part of the sequence, so I'm not going to write it up there as part of the sequence, but we do know it would be that 0th number, the number before the sequence. So when we look, what is the 10th number in the sequence? We're going to plug that into our x, the 10th number, our domain. The x is our domain. Those are our counting numbers, and we want to know the 10th one. Okay, so we have -5 times 10 is -50 plus 2, and our 10th number is going to be -48. All right, we have our last example here, and we are going to do the same thing here. It says it's a level 3. Let's see, all the numbers are bigger and different. We've got starting with a positive, the next one's a negative. Let's see, how do we do this? We follow the same steps. What is the explicit function? Remember, what goes in front of the x is the constant difference. I'm going to abbreviate there. How do we find the constant difference? It's what we are adding from the first term to go to the second term. That same thing we are adding every single time. Well, what are we adding? What do we add to 10 to get -40? Okay, well, if it's something that bigger numbers that's not always obvious, we're going to take the number in one of the numbers in the sequence and subtract the number before it. So I'm going to have -40 minus 10. That gives me -50. So my constant difference is -50. One thing I haven't done yet, which we should have been doing all the way along, is checking. So we're going to check. Should have been doing that. All right. Is that a constant difference? Is 10 minus 50, or is 10 add -50 give you -40? Yes. -40 add -50. Does that give you -90? Yes. -90 plus -50 gives you -140. Yes, we know that -50 is our constant difference. All right, we need to now figure out remember, this is our 0th number. Okay, that's the number before our first term in the sequence. So if our constant difference going this direction was we were adding -50, we want to work backwards. -50 is like subtracting 50. We're going to go backwards to find our 0th number and add 50. So the number before our first number here, our 0th number, we're going to add 10 plus 50, and that gives us 60. So our 0th number is 60. And we can find the 10th number in the sequence. You could find the 100th number. You could find the 1000th number. But we'll find the 10th. The 10th number in this sequence is -50 times 10 plus 60. So we have -500 plus 60, and our 10th number is going to be -440. All right, now you know how to write an explicit function of an arithmetic sequence. And have a great day.